Pop quiz. A silicon diode starts conducting at which voltage? Is it 0.07, 0.7, or 7 volts? Keep that answer in mind. We'll reveal the correct answer later. In this video, you will learn how to summarize a p-n junction diode in a single graph called its VI characteristics. Let's begin by setting up that graph. We will plot the voltage across the diode on the horizontal axis and the current through it on the vertical axis. Now let's examine what happens in each operating region, starting with forward bias. First, forward bias. That means the positive terminal is connected to the P side and the negative terminal is connected to the N side. So conventional current goes from P to N. What does the graph look like at very small forward voltages? At very small forward voltage, the current is tiny. The depletion region still acts like a barrier, so not many charges make it across. As you increase the forward voltage, that depletion region shrinks, and the current grows faster and faster. Eventually, we reach a turning point. The current suddenly becomes extremely sensitive to voltage. That point is called the cut-in voltage, or knee voltage. For a typical silicon diode, it is about 0.7 volts. Here is the key idea. Before the knee, raising voltage changes current a little. After the knee, the small change in voltage can cause a big jump in current. This leads to a common misconception. Some people think the diode is completely off until 0.7 volts. In reality, current increases gradually, but the rapid rise becomes obvious around the knee. So far, forward bias means current is small at first, then rises sharply around the knee voltage. Want to check your progress? Tap the link for a quick practice test and a concise study guide tailored to this lesson. Quiz yourself, skim the highlights, and jump back in. Now reverse bias. Connect the positive terminal to the N side and the negative terminal to the P side. The depletion region widens, so the diode mostly blocks current. On the graph, reverse bias sits on the negative voltage side. The current stays very close to zero, with only a very tiny leakage current in the opposite direction. And that tiny reverse current is almost constant for a wide range of reverse voltages, which is why the diode behaves like an insulator in reverse bias. One more important clarification. If reverse voltage becomes extremely large, a diode can enter breakdown and conduct heavily. In normal operation, you stay well below that region. Now step back and observe the overall shape of the graph. Notice this is not a straight line. That means the diode is non-ohmic, so you cannot use a single constant resistance the way you do with a resistor. Even though it is non-ohmic, engineers still describe the behavior in terms of resistance. In forward bias, it behaves like low resistance. In reverse bias, it behaves like very high resistance. To represent this behavior in circuits, we use a symbol. The symbol shows the P side and the N side, and it points to the direction the diode easily conducts to, from P to N. Now let's return to the pop quiz. The correct answer is B, about 0.7 volts for a typical silicon diode, where the current starts rising very rapidly. To recap, the VI graph shows a diode's whole story. Forward bias gives small current at first, then a sharp rise near the knee. Reverse bias gives almost no current except tiny leakage, so the diode mostly conducts in one direction. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.